Good morning, grade 8. How are you today? Today, we will start chapter 8, lesson 8, which is talking about factoring by grouping. In this lesson, we learn how can we factor higher degree polynomials by grouping. In lesson 8.5, 8.6, and 8.7, we dealt with polynomials have a quadratic degree, like x squared minus 3x plus 4 as an example, with a quadratic. Here now with a cubic or fourth degree, with a higher degree, how can we factorize them? We will learn today how can we factorize the higher degree polynomials. Now, in lesson 8.6, we factored trinomials of the form that has the form ax squared plus bx plus c. What did we do? The first step, we rewrite b of x in a sum of two monomials. That's mean if I have as an example 3x squared plus 2x as an example minus 4, let's say 12, 3 and 4, or make it as, yes, minus, and let's make this 3, this 2 as, let's say 3 to 4 times 4 is 12. Let's have a 12 as 3 times 4. Okay, so plus x. Or plus minus 4 minus 12 plus 7x. Yes, like this. If you have 3x squared plus 7x minus 4, the first step, where's bx? It is 7x. We rewrite bx as a sum of two monomials. So what did we say? We say it's a 3x squared plus 3 times 4, which is 12. So we write the factors of 12 that if you add them, you get positive 7, which is negative, it is here positive, which is positive 4 plus 3x. So you rewrite the bx as 2 of summation of monomials. Then after that, you can group them into two pairs. Then after that, we group them into two pairs. Then we factor the GCF from each pair and look for the common binomial factor. Then what did we say? We say let's put x outside here. Then we have a 3x plus 4 plus 3x plus 4. We find the GCF here. After that, we find the common factor times x plus 1. This was what we do, or what we did, if we want to factor a trinomials with ax squared plus bx plus c. We rewrite bx as a sum of two monomials. We then group the terms in pairs. We factor the GCF and we look for the common factor. This process, we called it factoring by grouping. This one, we called it factoring by grouping. And this way, we can also use it to factor the higher degree polynomial. Now, let's see how here. Factoring a cubic polynomial. What is the factored form of 3n cubic minus 12n squared plus 2n minus 8? The first step here, as we see, we have 3n cubic minus 12n squared plus 2n minus 8. The first step, I want you now to group the terms into two pairs. Let's now make them in this group plus this group. So the first step, I want you only to group these two terms into pairs. We have a 3n cubic minus 12n squared plus 2n minus 8. Then after that, factor the GCF of each pair. Let's look at the first pair. The first pair here, what did we have? Now what did we have here? We have 3 n cubic and 12 n squared. Sorry, I will make them big one. So here we have 3 n cubic and 12 n squared. Now let's factor them. If we factor them in, what did we have? We have a 3 times n times n times n. Let's now factorize them into the prime factors. And 12, we have 3 times 2 times 2 times how many n? 2 n's. Then after that, let's find now the GCF, the common factors, which is a 3, sorry, or you can see these 2 n's here. So 3 n squared. So the GCF here is 3 n squared. So let's write now 3 n squared as a common factor. Then after that, after we look at the common factors, look at each monomial. Which monomial will be left? We have n minus 2 and 2, which is 4. So we have here n minus 4. So we find the greatest common factor, then we factorize it. We look at the greatest common factor. We factorize them as a 3n squared times n minus 4. We wrote the greatest common factor, and then we wrote the monomials, that is, or the binomial, that is remain. Then plus here we have to do the same now, but with the second pair. We put 2n and 8. Let's factorize them here. 2 and n, 2 and 2 and 2. So the common here is 2 times n, which is left here, minus 4. So here now we have 3n squared times n minus 4 plus 2 times n minus 4. And after that here, we have now 3n squared times n minus 4 plus 2 times n minus 4. Then here, I want you now to write them as 3n squared times n minus 4. We have to find now the greatest common factor for them here. What is the common factor here? It was n minus 4. So I put n minus 4 as a common factor. Then I will write what will be remain, which is 3n squared minus 2. So now this is a factors form of a cubic polynomial. N minus 4 times 3n squared minus 2. We group them into a pair. We factor the greatest common factor. We look at the common factor. We write them. Then we write the binomial that is remain. Then now we wrote the factored form of the cubic polynomial. Now let's have another example here. What is the factored form of 8t cubic plus 14t squared plus 20t plus 35? Let's now rewrite it here. We have 8, we have 8t cubic plus 14t squared plus 20t plus 35. As we did before, the first step, let's group the terms into two pairs. This is now the first pair. and this is now will be the second pair. Then after that, now let's write them as 8t cubic plus 14t squared plus 20t plus 35. Then now factor the greatest common factor from each pair. Let's now start with the first pair here. We have 8t cubic with 14t squared. So it is 2 times 2 times 2 times t times t times t. Here it is 2 times 7 times t times t. Then take the common factors here, which are 2t squares. So let's take here 2t squares as a common factor. So which monomial will be remain? We have a 4t, as we see here, plus 7. Then plus, look at the second pair now, here, which is 20t plus 35. 20t and 35. Let's now factorize them. We have a 5 times 2 times 2 times t. We have 5 times 7. So the greatest common factor here is 5. Let's take 5 as a common factor. So we have 4t plus 7 is the binomial, which is we left. Then after that, as I told you before, let's take 4t plus 7 as a common factor. Then let's take 2t squared plus 5 in the second bracket. So by this way now, we factored a cubic trinomial into 4t plus 7 times 2t squared plus 5. Okay, now, sometimes for this example here, look at this example here. We have a 4q raised to the power 4 plus 8q cubic plus 12q squared minus 24q. For this type of polynomial, this is a 4th degree. Okay, this is a 4th degree. But they told me that before factor this polynomial by grouping, you must find the greatest common factor of all the terms. When I know this, when I know that if I start grouping or start with the greatest common factor. Look at the last term here. If the last term here, so I look at the last term here. Here it is 24q. If the last term is not a constant, it is a number with a variable, I will factorize, or I will find the GCF. If it is only a number, like this example here, okay, this one here, it's only a number, just I'll start with grouping them into 2 pairs. If it is here multiplied with a q, like this one here, the last term, it's not a 24, it's 24q. It's multiplied by a number. In this way here, I will use the GCF. Then after I find the GCF, I will use grouping, I'm factoring them by grouping. Or another thing also, if you find that the power here is cubic, The higher degree here is 3. You start with a grouping. If it is 4th degree, you will start with the to find the GCF first, then you will start with then we factors. So if it is cubic or with 3rd degree, I mean it is like this one, 8t cubic. You will start with grouping them into two pairs, then find the GCF. Then continue. If it is has a 4th degree, okay, first you have to find the GCF, then you have to grouping them into two factors. Then continue and find the GCF another time. So here now, you just, if it is a cubic, if it is 3rd degree, first you have to grouping them into two pairs, then find the GCF. If it is 4th degree, the first step before grouping, you have to find the GCF. Let's have an example here now. Look here. As we said now, it is a 4th degree. So the first step, let's find the greatest common factor of all of the terms, of all monomials. Let's find them as like this. 4q raised to the power 4. 8q cubic. 12q squared. And 24q. This is the first step. The second step now. It is 2 times 2 q, 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 q. Then it is 2 times 2 times 2 times the q times the q times the q. Here we have 3 times 2 times 2 times the q times the q. And here we have 3 times 2 times 2 times 2, which is 3 times 8 times the q. Then let's find now the greatest common factor. 2, 2, 2, 2. And also there's another 2. 2, 2, 2, 2. The 3, is it common? No. Q, only one Q here are in common. Or sorry, isn't common. So here, the greatest common factor is 2 times 2 times the Q, which is 4Q. So let's put here 4Q as a common factor. Then after that, look at the first term. If you look at the first term and we remove 2 and 2 and the Q, which will be remain? We have a Q cubic. Then minus. Here, what we'll have? We will have 2q squared. Then plus, look here. If you remove 2 and 2 and the q, what we will have? We will have 3 and the q. Minus. If you remove 4 and the q, what you will have? You will have 6. So this is now the first step. As I told you before, grouping or factoring by grouping, you have to find the greatest common factor by find write the factors of each monomial, find the greatest common factor and write them here. Then after we finish, we have them like q cubic minus 2q squared plus 3q minus 6. The second step now here, let's now grouping them. Let's now put them into two groups, this group and this group. So it's like q cubic minus 2q squared plus 3q minus 6 And please don't forget the 4q that I wrote it before. Then the second step here, let's now write this one here. Q cubic and 2q squared. Let's now write the common or the factors for them. Here we have q, q, q. And here we have 2q, q. So the greatest common factor here is q squared. So what we have to do now, we have to put q squared times, if you remove this 2q, you will have only 1q, and here you have 2. So you put them like this here now. Then plus, let's take now the second term, which we will have here now, 3q and 6. Let's factorize them. We have 3 and q, and you have 3 and 2. So the common factor here is 3. Let's put the 3 here now, times q minus 2. The second step now. Let's clear this here. Okay. Then after that now, what I forgot to write, 4q. Oops. Then after that, let's take q minus 2 as a common factor. If you remove them, what you will get from here, you will have q squared, which will be remain, plus 3. As I told you before, you just look at this term and this term. If you remove them, you take one of them as a common factor, you get q minus 2. Then after that, you will have q squared and 3. Well, these two monomials will be left, which is q squared plus 3. So here I will repeat, since I take q minus 2 as a common factor, so we will have here now a q squared plus 3 in common. They will be left, sorry, which I wrote them here. Then after that, let's now rewrite it. It will be, so the factored form of this trinomial here, it will be, let's write it here, let's draw here a square. It will be 4q it will be 4q I'm sorry, 4q times q minus 2 times q squared plus 3. This will be now the factored form of this trinomial here. Okay, it's 4q times q minus 2 times q squared plus 3. This is the factoring for the factored form of this polynomial. Let's have another example here. What is the factored form of 6h raised to the power 4 plus 9h cubic plus 12h squared plus 18h? Factor completely. Here now, as we said, if we have a 4th degree and the last term is multiplied by h, let's, the last term, it's not a constant, it's multiplied by a variable. The first step, you have to find the greatest common factor of them. We have a 6h raised to the power 4, 9h cubic, 12h squared, and 18h. Then 6, it is 3 times 2 times h times h times h times h. Here it's a 3 times 3 times h times h times h. Here it's a 3 times 2 because the 12 it's a 3 times 4 and 4 it's 2 times 2. So it's a 3 times 2 times 2 times h times h. And the 18, I will write the prime factors for it. It was 9 times 2, so it's 3 times 3 times 2 times h. Now let's find the greatest common factor here. 2 it's not, and h. So there we have 3h as a common factor. Let's write here 3h. Then if you look at the first monomial here, 6h to the power 4. If you take 3h as a factor, which will be remain 2h cubic. Plus, look at the second term here. If you remove the 3 and h, which will be remain 3h squared plus 4h plus 6. This is now we find them, or if you find now the group, the greatest common factor of them. After that, now we have a cubic polynomial. This now, let's now do it as we said before. The first step, grouping them, I will group them into two pairs like this. 2h cubic plus h squared and 4h plus 6. Cut them into two terms. So we have 2h cubic plus 3h squared and 4h plus 6. This is now the two pair of factors, factors as we wrote them. And don't forget the 3h. Then after that, now here we have, after we grouping them, as I told you, find the GCF, grouping them, then find the GCF. Let's find the GCF now for the first pair here. We have 2h cubic and 3h squared. It is 2 times h times h times h. And here it's a 3 times h times h. So we have an h squared in common. If you have h squared in common, what will be left? 2h plus 3. Then plus, look at the second one here. We have 4h and 6. Let's grouping them now. 2 times h and 3 times 2. So what is the common factor? Look at the common factor here. We have a 2. Let's write 2 here. Then write what will be left. 2h plus 3. Then after that, now all of this, don't forget, it's multiplied by 3h. Then after that, now then let's now continue here. As we said, if we have a 2h plus 3, so you take them as a common factor, what will be remain? It will be, we will have h squared plus 2. This will be now the second bracket. Now these two factors, don't forget, they are multiplied by 3h. So now, by now, we learn how can we factor a trinomial with a fourth degree. And its answer is 3h times 2h plus 3 times h squared plus 1. Now, So now they're here as a summary of what to remember as you factor polynomials. That's what we studied in lesson 8. In lesson 8, as I told you, we learn how to multiply. We learn how to multiply two factors to get a polynomial. And in the second section, we learned how can we factorize a polynomial into factors. So to factoring a polynomial, you can factor out the greatest common factor. This is one of them. Or if the polynomial has two terms or three terms, look for the difference of two squares. If the polynomial has two terms or three terms, look for the difference of two squares, a perfect square trinomial or a pair of binomial factors. So if it has two terms, so it could be a difference of squares. As we said before, we have like x squared minus 4. These are a polynomial, okay, but with two terms. If it's like this with two terms, you have to find to solve it as a difference of a square, sorry. And don't forget, we must have a perfect square in the first and the last terms. The second one, if you have a polynomial with three terms, like this one as an example, okay, and the first term and the last term are a perfect square, okay, and if you multiplied the first one with the second one with 2, you get the one in the middle. This one we will use a perfect square trinomial. So we can factorize. If we have two terms, we will find a difference. You will factorize them as a difference of square. If we have three terms, we have to look at the first and the last term. If they are a perfect square and the middle is 2 times the first and the last, you will use the perfect square trinomial. If it has a three terms also, like x squared minus 3x plus 2, okay, and the first and the last term are not a square or a perfect square, you will grouping them into two, or you will factorize them into two products of factors, which is x minus 1 times x minus 2, as we learned before. We must start the factors of 2, then choose the pair of factors that if you add them, you get a 3. If the polynomial has 4 or more terms, as we learned today, you have to group the terms into pairs and then factor to find the greatest common binomial factors. As a final check, make sure that there's no common factors other than 1. At the last, if you see as an example, after you factorize them, you see one of your factors are 4x minus 6 as an example. After you factorize, you finish, what did you do? You find one of them is 4x minus 6. Don't stop here. Why? Because there's something in common between them, which is number 2. So don't stop here. Make sure that there's no common factors than 1. If you look at now 2x minus 3, you will find that there's no common factor between them other than 1. So you will stop at 2 times 2x minus 3. This is now all the ways of factoring polynomials. It is very, very important. You have to know all of them, because next time you have in grade 9, 10, and 11 also, you must know how can we factorize any trinomial. Don't forget, you can write them as a product of 2 factors, you find them as a difference of square. You can use a perfect square trinomial, and each one has a case. It is a case. You know when you have to use the perfect difference of square, when you have to use the perfect square trinomial, and when you have to write them as a product of factors. And sometimes if you have a 4 terms, don't forget four terms, you have to grouping them or and then factorizing them. Or sometimes you have to find the greatest common factor before grouping the terms. Here now we have these two. If we have here 4 examples, I will explain it tomorrow. Thank you.